So continuing to solve rational inequalities, what makes these next two different is we're not greater than or equal to or less than or equal to 0. We're greater than or equal to the something else on the other side. So again, visually what we're doing is we're looking at two graphs. We're looking at a rational graph and figuring out when's it sitting below the horizontal line y equals 1. Or here we're comparing two different rational graphs and figuring out when's this graph below that graph. So basically the analysis is the same. So step one, let's make sure what makes us undefined. Well, what makes us undefined clearly is x equals -3, right? So there's a division by 0. And then what makes us equal to? Well, we have to solve the equation, right? 2x minus 3 over x plus 3 equals 1. And of course, we can't use our x-intercept analysis because we're not 0. So we actually do have to solve this equation. So multiplying both sides by x plus 3, that clears things out. We have 2x minus 3 equals x plus 3. Subtract x from both sides, add 3 from both sides. I think what we're eventually going to get is x, right? X equals 6. So there's the value that makes us equal to. So now what I do is I come to a number line, right? Now that I've found what makes me undefined and equal, we have -3, and somewhere down here we have 6. Of course, we know in between is 0. And so we basically have an interval to the left of -3 we got to test, an interval between -3 and 6 we got to test, and an interval to the left of 6. Oh, and by the way, 6 makes us equal to, but since we're a strict inequality, right, it doesn't really matter. For both of them, we're going to use an open circle to represent them because equality is not allowed. All right, so we can't be equal to -3. We can be equal to 6 technically, but we're not solving the equal to. So testing my intervals. Again, right now we'll probably go ahead and just find the value. So x, right, how about we let it equal -4. So when I plug it in here, 2 times -4 is a -8. Minus 3 gives us -11 upstairs. -4 plus 3, well, that's -1, and we get 11. So is 11 greater than less than 1? Well, the answer is no. Right? It's a false statement. So we're not going to be there. In the next interval, x equals 0 is available to us. So when I plug it in here, we get a -3. When I plug it in here, we get a +3. We get -1. So is -1 less than 1? The answer in here is yes. The next interval, x equals 7. So again, 2 times 7 is 14, minus 3 is 11. 7 plus 3 is 10. And is 11 over 10, is that less than 1? Well, the answer is no. And so looking at my no's and my yeses, my pluses and my minuses, if you would, right, it looks like this stretch is the only one that actually works for us. So from -3 to 6, right, that would be the interval where this graph is actually below that graph. Okay? So again, visualizing this, you know, there's basically the graph of the of 2x minus 3 all over x plus 3. And then let me come down a little bit here. The graph of y equals to 1. Let me turn that on. Turn on. There we go, right? And so there's that graph, and so we can actually see, right, that so starting right around, oops, I have the wrong value. That should be 1. Just thought something was a little weird there. This is 1. There we go. So starting at 1, so we can see that at -3, right, we know that there is, right, 1, 2, 3. We know that there's a definition there. And here's y equals 1, and here's the function. So it is, starting at -3, the graph is below the graph of 1, all the way up to about 6, right? This is where they actually equal to each other. And at that point, the graph of the rational function is still below y equals 1, but then past +6, the graph of the function is actually above 1. So we can basically see from 6 to -3, right, the function graph actually is below the other graph. All right. Of course, if you wanted to, rather than analyzing two graphs at once, I can come to that original function, right? I could subtract 1 from both sides, and basically we can now analyze the x-axis, right? And so there's what happens if I subtract 1 from the graph, and we can see that, right, it's below the x-axis at 6 and at 3, and then past -3 and past 6 it's above. So what I'm doing there is I'm moving things over and setting it, you know, with the 0 there, and doing kind of the analysis that we did there. So whatever rocks your world, whatever seems easiest to you, right, that's how we do that. So either way, but there's basically our answer. So the next one, again, step 1 is to figure out where we're undefined. Well, clearly, right, x cannot be equal to 3, and x cannot be equal to -1. So there's where we're undefined. Where are we equal to? When does this graph equal that graph, right? Well, we have to basically solve that equation. And I think a quick cross multiplication is due here. So 5 times x plus 1 is 3x minus 3. This is 5x plus 5, 3x minus 9. If I subtract 3x from both sides and subtract 5 from both sides, I think we get 2x equals, what is that going to be, a -14. Dividing both sides by 2, we get x equals -7. So here's where we're actually equal, and that's going to play a role in the solution because we do allow equality to happen. So now that we found out where I'm undefined and where I'm equal, all right, what we're going to do next, let me just double check my math here. Yeah, -9, yeah, okay. That's a negative, yep. So -7, and we have -1, and we got +3. We know that we're allowed to be equal to here. We can't be equal, and we can't be equal to. So open, open, and closed here because we're allowed to be equal. Equality is allowed. So we basically have to test 3 intervals in this inequality to kind of compare. So x equals -8. When I plug that in here, I get 5. -8 minus -3 is -11. And we want to know, is that less than, we got 3, and -8 gives us -7. So is 5 over -11, is that less than 3 over -7? Right? Kind of hard to tell, but if we do a quick, forget the negatives for a moment, right? If we do a quick cross multiplication, we get 35, right, less than 33. All right, and so this means that this graph is actually to the left. All right, so I think we basically have our solution there. Okay, let me just look at that real quick and make sure that I am satisfied there. Yep. So that is a true. Well, we got -35, right? Don't forget the negatives. So I think we do actually have a true statement right there. That. Okay. So we are. The answer is yes. -5 over 11 is in fact less than -3 over 7. Let me just double check that. Something's not. I'm just going to go to the calculator. I'm trying to fight the urge to use it. So we got 5 divided by 11, right? So this is -4.445, and then 3 divided by 7. Well, that's -4.28. Yeah, so that is, so we're true. We're a yes there. So a little bit harder to check. X equals -2 is in the next interval. So we get 5. -2 minus 3 is a -5, so we get -1. Over here we get 3 over -1, right? So -2, right? And so we get -3. So is -3 less than -1, right? And the answer to there is no, right? In terms of number line, that's not a true statement. X equals 0 is a nice one to test. So we get 5 over -3, and we're trying to figure out, is that less than 3 over 1? And is -5/3 less than 3? And the answer there is a resounding yes, right? A negative is always less than a positive. And then x equals 4, we get 5 over 1. Is that less than 3 over, that's going to be 5. So is 5 less than 3/5? And that one's a resounding no. Okay, so there's our analysis. Taking a look at our yeses and our nos, we're going to color that part of the x-axis. We're going to color that part of the x-axis. And so it looks like my solution interval notation wise is negative infinity up to negative 7, including that, union between negative 1 and 3. All right, and so that's basically when this graph here, right, is truly less than or equal to that graph right there. And to double check this, what I'm going to do is I'm going to actually kick this over. It's a little bit easier to compare it along the x-axis. So that's what I'm going to do to verify that this graph, it's a little bit easier to do it that way. So when I go look at my technology here, there's that graph, right? And oops, let me come out. And so you can definitely see that at negative 7, we do seem to be crossing. We're below and then we're above, right? And then starting at the asymptote of negative 1, which is, or excuse me, yeah, at negative 1, so from negative 1 to 3, the graph is definitely below the x-axis. And then past 3, it's above, and then past negative 7, it's above. So my graph kind of verifies what we have there, right? So there you have it. So a little bit tougher when we're not set equal to 0. We probably actually do have to compare the values. So have at that. Again, the idea, what makes me equal, what makes me undefined, and then going from that route. All right, so that covers rational expressions. Got one more round of inequalities that I'm going to do, and we'll wrap up 5.6. Talk to you guys in some videos coming soon.